Lesson 15 today, air intervals. Okay, so this is still on the same lines as percent air, page 111. First question, industrial scale is guaranteed by the manufacturer to have a percent air of no more than 1%. So is it possible, reading on the scale, that you put 500 kilograms of iron ore on it? So whatever you guys use, whether a scale or a gas pump, for instance, it's not always exact. They get a little percent air. It's not going to be perfect. Okay? If you've ever filled up a gas tank, you know at the end when you even click it off, there's more that comes out, dribbles out of there, right? So same thing with weight. It's not always going to always have to be 500.000. Okay? They have a percent air. So here we're allowed 1% air. So I got to figure out how much leeway that gives me. So I got to figure out 1% of 500. Anybody know how I'd figure that out? How do I figure out 1% of 500? Move the decimal over 2 spots. Because I'm taking 500 times, what's 1% as a decimal? 0.01. So what is 500 times 0.01, or if you just move the decimal 2 spots to the left? Rylan? 5. So that's my air. I'm allowed 5 kilograms of air. So what is the possible reading on this scale? So what is the smallest that would show up? If I put something that's 500 kilograms on the scale, it's allowed 1% air. What is the smallest amount that could weigh? 5 less than that, right? So 495 kilograms. What is the most it could weigh? 5 more than that. 500, which would be 505. So it's going to have a range somewhere in there. That is the air interval, as the lesson is called. It gives us a range that's okay. The allowable range. Okay, question 2. Boston, would you read it, please? Talking about the sawmill.
Sawmill cuts boards that are 16 feet long. After they are cut, the boards are inspected and rejected if the length is a percent air of 1.5 or more.
Okay, so what is 1.5% as a decimal? Move it over 2 spots to the left. 0.15 is correct. All right, so first thing I'd like you to do is multiply that. Be careful where your decimal goes. Once you have that done, please check with a neighbor. If you agree, please let me know. Just multiplying them. Faith?
0.24.
Got a label?
Feet.
0.24 feet. Now you could take it times 12. It's going to be just shy of 3 inches if you want. Now we're just going to leave it feet for right now. So if you go buy a 16-foot board from this sawmill, you got some leeway. So what is the biggest board that would be allowed that they can still sell for 16 feet?
16 feet.
Add this to it, right? 16.24. So 16 plus this number. What is the smallest allowable? So I got to take 16 feet minus 0.24. 15.76. So if you go to this sawmill and you need a 16-footer, hopefully you don't end up with this one, right? They could still sell that as a 16-footer at this sawmill, but you'd get home and your board would be short. So give me a board length that would be acceptable for that sawmill to sell. Give me one. 15.8 feet would be accepted to sell because it's in that range. Rylan.
15
6.87 feet. One more, Reed.
16.17.
16.1 what?
7.
7. So anything in this range, you can write down for A. It says some, I listed 3. B. Give me a board length that would be rejected. And have it be close. Don't say like 1 foot. Obviously, a 1 footer would not be even close to 16 feet. Jonas.
15.5.
15.5 feet would be rejected. It is not in that range. Connor. 16.25 would be rejected. And one more, Maverick. 16.5 feet would be rejected. Again, I just listed 3. List as many as you want. It's got to be outside that range. Okay, question 2. Molly, would you read question 2, please?
The owner also cuts boards that are 10, 12, and 14 feet long. When the inspector rejects a board that was 2.3 inches too long, what was the intended length of the board?
Okay. So, it's going to be a 10-footer, 12-footer, or 14. Those are our options. And I got to figure out the intended length. All right, so I'm going to put my work over on this page here. And I'm going to talk about the 10-footer first. All right, what was my error again?
1.5%.
What was that as a decimal? Okay. So I would like you to multiply that one for me. See what you get. Nope. Not 1.5. Yep. Yeah, just move the decimal one spot, right? 0.15. Now that's still in feet. Since number 2 is asking us in inches, please take it times 12. And that'll tell us the biggest amount of error that it could be. So because, again, they put it in inches, we got to take it times 12 to get feet into inches. Boston. Got it?
I'm not done yet.
Kellen.
I got 1.8.
1.8.
Yeah, I just added them. Yeah, my bad.
Okay, so that's the biggest error we could have. So if it's 2.3, would that be rejected as a 10-footer or accepted? This is the biggest error I could have.
Rejected.
This one, if it's a 10-footer, it would be rejected. Okay, now let's try a 12-footer. Actually, you guys can each do one. Ladies, you're going to do the 12-footer. 12 feet times the error. And then take it times 12, please. Gentlemen, you're going to do the 14-footer times the error. And then times 12. Jonas?
I got 2.52 inches.
Yes?
I got 1.5.
I got more than that. 2.16. Okay, just to double check your multiplying there. Ladies, you should have had 0.18 and then took that times 12. Guys, you should have had 0.21 taking it times 12. All right, so again, remember the error it says in problem 2 is 2.3 inches. So would a 12-footer, would it get rejected or accepted? Rejected. 2.3 is out of that range. How about as a 14-footer? Accepted. The error is less than the acceptable amount. 2.3 is within that range. So let's go back to the question now. It tells me the inspector rejected the board. So they threw it out. Too big of error. So what are our options that would have been rejected? So it had to be a 10-footer or 12-footer because both of those were rejected. Could not be a 14-footer because that wasn't within the acceptable range. I'm guessing you don't check them all. I'm guessing you check random. All right, question 3. Again, we have a kind of a card sort here. We're not going to get in groups today. I'll show you the card. You tell me what kind of information we need, and we're going to solve it. So just on page 113 there, you got a bunch of blank spots. Let's solve one. Your options, I'll let you choose which one you want here. Here's your options. Card 1 or card 2? 1, 2. Good. Glad we decided together.
Yes. That was a good
Let's do
decision.
number 3.
No, we just made an executive decision for five. We're doing all.
Let's do 3.
One.
All right, raise your hand. Who would like 1?
Executive decision is 1.
Who would like 0?
Who would like 2? All right, 2 wins. All right, so we're going to do question 2.
It's an executive decision.
Question 2. All right, so read number 2. Cameron, would you read it out loud, please?
A machine is supposed to fill each bottle with the same amount of juice. A particular bottle was tested and the percent error was not too large. How much juice was in the bottle?
Okay. So we got to figure out how much juice is in a bottle. So first thing you need is some numbers, right? Some data. So what kind of things are we missing?
How much juice is in the bottle? That way we don't have to soda.
How much juice, how about was supposed to be in a bottle?
Okay, that works good.
All right, so here's how much juice is supposed to be in a bottle. 450 milliliters.
How large of a percent error?
How large is a percent error? To pass the test, the bottle must be within 1.5%. One more thing you need to know.
What kind of juice is there?
Not important.
Not easy enough. As long as it's not really good.
What percent error is like the actual, like what the answer is?
Yeah. So the only other thing we need to know is, are the bottles overfilled or underfilled? If you don't ask that, you're just going to have to list the whole range like we did for the first question today. Okay, which is fine. All right, so same percent as before, so that should be an easy as a decimal, right? 450 times 0.015. So please do that, see what you get. That'll tell us what our leeway is on each side of 450. Read.
6.75.
Anybody confirm 6.75? Faith, Kinley, good. We'll go with that. Again, decimal placement's going to be important here. All right, so what is the most amount of juice that could be in there to be accepted?
456.75.
Add it to 450. What is the smallest amount of juice that could be in that bottle and be accepted? So then it's going to be 450 minus 6.75, right? Point what? 2.5? All right, now if it said all the bottles were overfilled, we would only look at the big side. If it says they're all underfilled, we'd only look at the less side, again, depending on if you asked that or not. This would be our full range. If it was overfilled, again, it would just be the high range. All right, let's take a look at the homework. Starting on page 114. Before we go too far, please put an arrow on 115 because there's a part B. So you don't miss that on page 116. I don't know why they put the one question there, but they did. All right, I want to talk about one just a second after Kellen reads that for us.
Determine the height of a pump in a size experiment and finds that to the limit 1.3 inch it is 4 3/4 feet. What is the largest the actual height the plant could be?
All right, so it says it's actually 4 3/4. You kind of got to know how to read a tape or ruler on this one. So 4 3/4 is right here. So it wants to know what's the biggest a plant could be that would still round to this, to the nearest 1/4 inch. So obviously it couldn't be 5 1/4. It's not going to round to this number. So does anybody know the biggest? Yep. 5 would probably just stay 5. They're not going to round it back a full 1/4 inch. Yep.
4.5.
4.5 would be the low side. Yes, that would answer B. 4.5 to if you're going to the nearest 1/4, just above 4.5 would round to 4 3/4. Yeah, 4 7/8 probably. And maybe we should adjust that other one, Reed. I thought it was nearest half there. It's nearest 1/4. So it'd be 4 7/8 would be right here. It would round back to 4 3/4. Anybody know what this number is? This would be a 1/4 low or an 1/8 low. We're gonna adjust B there, Reed. 4 6/8 would be 4 3/4. So what's an 1/8 less than that? 4 5/8. 4 5/8. All right, so we basically moved an 1/8 of an inch. Anybody remember 1/8 of an inch as a decimal? Because we're going to need it for C. 0.125 is correct. Divided by what was it actually? 4 3/4. What's that as a decimal? 4.75. And I'll let you divide that out. And then number 1 will be done there for you. Problem 2, write an equation. 2 equations. This is a little review. Just to give you a start, it's going to be W equals, once you get 1, remember you reciprocal and flip the variables. Question 3, I think we can handle, pretty self-explanatory. Question 4, top of the next page. Remember, you're going to make that a decimal and figure out the the error using that. We've done all 1.5%. This is 1.6. Sure, we can handle that. Question 5. Again, a review of scale factors. Kind of need to remember how to figure out area of a triangle. Base times height divided by 2. So 3 times 2 divided by 2. That number will go right here. And then you should be able to figure out the rest of the chart. Be careful. Remember what you do to area when you increase the scale factor. Square the scale factor when you're dealing with area. So if it's twice as big, how much bigger is the area? 2 squared is 4. 4 times bigger. All right, and then don't forget to be on the next page. So that will be due tomorrow.